Hello. So in this lesson, we're going to look at starting with. Sorry. In this lesson, we're going to look at analog write. So far we've done digital write, we've done digital read, we've done analog write, we've done analog read, but we've not done analog write. So have we done digital read? I think so. Yeah. In this lesson, we're going to look at analog write, and in doing that, we're going to use the RGB LED. We'll also look at how to map values. Yeah, we are going to apply some of our old lessons, things like variables. So let's begin. I've already done the circuit. This is a circuit. This is the RGB. On the RGB, this is the red, this is ground, this is blue, this is green. As usual, you want your student to Google what is RGB and have an idea what RGB is, what the RGB LED is, and what it is used for. You will also like to do the same. You want the discussion with your student to not be one-dimensional. So since it's an LED, you know, when we are using LEDs, we add resistors because so that the current is not too much for the LED. So we add resistors to the red leg, the green leg, and the blue leg. So then we wire them to the pins. But take note that we are writing analog values, not digital values. But here you can see that I still connected the LEDs to digital pins. But if you watch carefully, all the digital pins have this sort of approximate sign on it. So what it means, basically what that means is that this pin allows for analog signals, and known as pulse width modulation. So you see PWM, and that's the sign. So the pulse with the PWM sign is beside them. Hence, they can also serve as what analog outputs as well. So that's why we use it. So if you use it with 12, 13, it's not going to work for you. So in all this, I've connected this to ground and wired this to ground also. So my circuit is complete. I repositioned the Arduino here just to make my connection easier as I saw or as I see fit. Now when we come to the code, the first thing you need to do is that you need to have your student create variables for the red LED, green LED, blue LED. However he decides to text it or write it is up to him, and then assign values or assign pins to those variables. That's 9, 10, 11 as we have done here. Then we also need to set the various pins to output, and that's what you see over here. Simple. Now since you would have done your research on RGB, you know that RGB allows you to mix red, green, and blue light. So basically what we're going to do is that we're going to write, since these are analog signals, it is no longer high or low or on and off, it's values, and the RGB takes values from 0 to 255. So here I'm saying that analog write for the red LED 255. It means the red is going to be 4, and I'm saying that green LED should be 0, blue LED should be 0. This means that the RGB light would light up color red, because only the red will be shown. Over here I do the same thing, just that only the green will show here too, only the blue will show. So, and I put a delay of 1000, that's 1 second, 1000 milliseconds being 1 second between them. I left this space just so that you see it clearly. It's not for syntax purposes. Over here I decided to mix up the colors a bit, so I just went online to look for fancy colors, and their RGB values, and I found one. Also note that mixing colors can vary. When you mix colors pigment wise, it's different from when you mix colors light wise, if my memory serves me right. So something like these are HTML colors. It would kind of vary in this case. Also too, because we are using a software, so these colors might not be as accurate as we want. So I picked values for some colors here, and then I computed. So if you see a color like this, 128 1280, it means that red is 128, green is 128, blue is 0. So then I can come here, I did it, red being 128, green being 0. So I mix it up just to get my own effect. So after a student has done that, so here is normal colors, red, green and blue. Here is a mixture of colors. Now when you run the circuit, so red goes to blue, goes to green, then it begins to mix the colors. You see, green begins to, okay, then mixes the colors a bit. So you see some variations in there. I don't think it's accurate though. That's the mixture of the colors. Also, the program is not running as smoothly as it's supposed to because I'm using the recording software. Okay, so at this point we've learned how to write values or write analog values onto our Arduino board. Okay, now let's come here. Over here, once again, we are going to write analog values. We've already used the potentiometer and we know how to read analog values from the potentiometer. Now what we're going to do is that we are going to take these values and then use these values, write these values onto our LEDs. Same circuit is here, same connection is here. Now the other side to this is that the RGB takes values of 0 to 255, but the potentiometer produces values from 0 to 1023. So we need to map the values. Mapping the values is kind of like ratio and proportion. If 1 is to 200, therefore what will 5 be? So we're going to do it over here, and I threw in a few things just to make things a bit more visible and clear. So over here, our usual variables, then I created another variable called pot, which I called A0. You can leave this out if you like, but I created it called pot. That's the potentiometer. A0, that's the pin for the potentiometer, and I created another variable called val, but I have not assigned a value to it because we are going to assign the value over here in the loop. And I want to see the potentiometer values. I want to see what is happening in terms of in text form. So I've initiated the serial monitor with serial.begin. So this is something that you have your student do stepwise. Now I want to see the value. So there are going to be two values. The normal value, that's the value of the potentiometer from 0 to 1023. So I'm calling that normal value. That's just how I decided to call it. So I've written serial.print normal value. Now take note, I didn't say serial.print line. I said serial.print. Print line is when it has ln. I said serial.print. Basically what serial.print does is that it allows you, when it writes something, it doesn't go to the next line, it stays on the same line. Serial.print line is after it writes it, it goes to the next line, or after it prints it, it goes to the next line. So we want to put the normal value and this text, so we'll say normal value, then we'll put the value there. So we need them on the same line, so hence we have serial.print. So I think this is something new that the students will also be learning. Then we have print line. We have the analog read of what the potentiometer value, which is A0, which is what I assigned in at the variables section. Then now the value that I declared, the VAL that I declared up there, now I'm saying that this val or value is equal to the analog reading, whatever is being read. Now this is a code used anytime you want to map values. You want to maybe either reduce the size of a value or increase the size of a value in proportion to what you are using that value for. So then I say val is equal to map, and then I write this. This, you will find this at Arduino over here, how to map an analog value. So you can just type mapping in Arduino and it will bring you in Google. The first link you will see will bring you here. So here it teaches you how to map. First of all, you need to assign the value to the reading, val to the reading. Then the val you write map open bracket val. Then the two extremes of the values you are getting, that's 0 and 1023, and the two extremes of the values that you want to convert it to, that's 0 to 55. So that's what I have done over here. You can see that. So once I get my new value, so val is now going to change to a value between 0 and 255. Once I get this value, I want to print this value as a new value, saying mapped value is now this. Hence I use the same print dot print or dot print line, and the next line I use dot print line. After I've done that, I now want to write that value. So now basically we are going to get a value between 0 and 255. So I say, okay, AnalogWrite, the red LED should have the value that we are receiving. But if we want to mix it up and get different colors at different points, you want to put in other numbers for the other colors. So here I said that, okay, let the green LED be 255 minus val. So at every point in time, when red is 255, green will be 0. But there will be colors in between 255 and 0, where green and red will mix up. Now you can decide to maybe swap it. You can decide to put your 255 minus val here, or put val here. You can mix it any way you want to. So let's run our simulation. Let me clear this. Let's run our simulation. So now you start seeing, okay, normal value is 0, map value is 0, normal value is 0, map value is 0, and it's on blue. The color is blue. Now, not sure why the color is blue though. Now as I move it, as I said, the code is not responding as fast as I want it to. As I move it, you realize that the color begins to change, and now you can see normal value is around 450, map value is around 112. You get it? So as I continue moving the potentiometer, I'm getting new colors. Now the color is 10 more pinkish because it's going to red. Because it's going into the red zone. So now you can see normal value is 1003, map value is 215. So basically this is it, and this is where we are. So this is what you'll be doing with your student. Let him go over a couple of times. Make sure that he knows all the references that you are using, and he knows how to get those references himself as much as possible. This would have been very exciting with an actual RGB. Hopefully from next week, or from when he gets his kit, he would be able to use them. Thank you very much.